over here, I've given you two matrices, matrix A and matrix B. And given this information, I've asked you to find a few quantities. Go ahead, pause the video if you know how to do this, and try solving it on your own. Otherwise, I'm obviously going to go over the solution. So let's go ahead and do that.
So before watching this video, you should know that I plan to make videos covering the entire undergraduate linear algebra curriculum. So make sure that you subscribe to my channel and turn notifications on, and you'll know when I post a new video that'll correspond with the concepts you're covering in class. Also, I plan on making review videos that cover these topics at a faster pace. Check my channel if I've released those already, because that will be useful to you if you already know this concept and you don't have to sit around with a more in-depth explanation, and you should get the content across faster. Okay, cool. With that, let's get back into the video.
Okay, so before we actually go ahead and solve this problem, the first thing I need to teach you is what a transpose exactly is, because we haven't covered that yet. So the transpose of a matrix essentially flips the rows and columns of the matrix. So let me just show you what that means with matrix A over here. So to do part A, we need to find the transpose of A. The transpose is denoted by a superscript of T over the matrix. So this right here just means that we're finding the transpose of A. So the transpose of A, or A transpose, is equal to the matrix in which the rows and columns of A are flipped. So here, row 1 would become column 1. So instead of 1, 2, 4 going horizontally, 1, 2, 4 would go vertically, with each entry in the row corresponding to its respective entry in the column. So the first entry in row 1 would correspond to the first entry and the first entry in column 1. The second entry in row 1 would correspond to the second entry in column 1, and so on. We can do this for each row in the matrix. So we do the exact same thing for row 2, which becomes column 2 in the transpose. So the first entry 3 would become the first entry in the column, and so on for 2 and 1. So this is A transpose over here. All we did was flip the rows with the columns. Row 1 became column 1, row 2 became column 2. Over here, since this was originally, we had 3 columns and 2 rows, this was a 2 by 3 matrix. Since we flipped the rows and columns, A transpose becomes a 3 by 2 matrix, since all we really did was just take the rows and make them into columns. So that's how you find the transpose of a matrix. And this is a very important operation because a ton of stuff that we're going to do in the future stems from the idea of finding a transpose. So it's important that we understand what it is. Okay, so now that we understood what a transpose is, the next step is to try and apply it to these specific quantities over here that I selected for you. And the first one we're going to do is find AB transpose. So I want to take matrix A multiplied by matrix B and find the transpose of that. If you don't know how to multiply matrices, I recommend that you watch the video that appears in the top right corner, because I go over how to do matrix multiplication in that video. But here I'm just going to assume you know how to do it. So before we do the matrix multiplication, we want to find out whether it's possible or not. Over here, I've already written the size of matrix A, and matrix B has 3 rows and 1 column, so it's 3 by 1. Since the columns in matrix A and the rows in matrix B are the same, we can safely apply matrix multiplication legally here. So AB exists, and we can find it by doing matrix multiplication. So AB, we can just write out the matrix. So 1, 3, 2, 2, 4, 1 multiplied by 2, 1, 3. And we want to take this, and we want to find the transpose of it. Because this is A, this is B, and we want to find the transpose of AB. So to do that, we just carry out the matrix multiplication. So remember, it's rows multiplied by columns, so we're going to get a 2 by 1 matrix as the resulting matrix of this matrix multiplication. Since we have a 2 here and a 1 here, we're going to get a 2 by 1 matrix. The first entry is going to be 1 times 2 plus 2 times 1 plus 4 times 3. So that's 2 plus 2 plus 12. So that's 4 plus 12, so that'll be 16. And the second entry is going to be 6 plus 2 plus 3. So 6 plus 2 is 8 plus 3 is 11. So 11. And this right here is equal to AB transpose. That's AB transpose right there. We found it by just well, sorry, that's just AB right there, my bad. And we found it by just taking A and multiplying it by B. Now, to find the transpose of this matrix, all we have to do is switch the rows by columns. So AB transpose should equal 11, well, 16, 11. Since we only have one column and two rows, well, we'll have two columns, the final matrix, and one row. This is the first entry in the row, and this will become the second entry in the row. We just flip the rows by columns. So this is AB transpose. So now this should be the answer to part B. Let's do part C. So part C asks us to find B transpose and multiply that by A transpose. So B transpose is going to be 2, 1, 3. And we want to multiply this by A transpose, which we found in part 1 already. I erased it, so I'm going to have to write it again. It's going to be 1, 2, 4, 3, 2, 1. And over here, and this is A transpose over here. Let me just write that out because I wrote B transpose. So now over here, we can just go ahead and carry out the matrix multiplication. So it's rows by columns. So over here, we're again going to get a matrix that well, let's just make sure this matrix multiplication is possible in the first place. So here we have one row and three columns. This is 1 by 3. And here we have 3 rows and looks like 2 columns, so it's a 3 by 2. Since the columns of this matrix are equal to the rows of this matrix multiplication is possible and we can actually do it. So now that we know it's possible, let's actually perform the matrix multiplication. So here we multiply the rows by the columns. So 2 times 1 is 2 plus 2 plus 4. So 2 plus 2 plus 4 should be 16. So 16. And then we'll have 2 times 3, which is 6, plus 2, which is 2, plus 3. So that's 8 plus 3, which is 11. And over here, we see that we get the exact same quantity over here. B transpose times A transpose is equal to this. And if you look up here, that's the exact same thing we got for AB transpose. So by performing this operation, now this isn't a proof. I haven't proved anything to you because this is just one specific scenario. We need to prove it for every single scenario in order to do the proof. But I've just shown you that it's most likely true that we have that AB transpose is equal to B transpose A transpose. And this is a property of the transpose that is in fact true, and it's been proven. I just showed you an example of where it holds true, and it holds true in every single scenario. So AB transpose is equal to B transpose times A transpose, and we showed it using these two example matrices. There's another property I want to show you that corresponds to these two matrices. So let's go ahead and do that. But for now, I just want you to appreciate the fact that if we have AB transpose, we can write that out as B transpose A transpose. And that makes certain matrix operations easier, where you only have to do one of these operations and both of them are the same. So now let's go ahead and do the last two bits, bit D and bit E, where I also have another property of the transpose that I want to show you. So let me just get rid of this so we'll have space to work with, and we can do part D and part E. Okay, so part D asks us to find C times A and then take its transpose where C is 2. So let's do that. We can take C times A and, well, let me just do that right here. C times A, where C is just 2 and A is this matrix right here, is going to equal, remember, we're just multiplying a constant by every single term in A, so we just go ahead and do that. 2 times 1 is 2, 2 times 2 is 4, 4 times 2 is 8, 2 times 3 is 6, 2 times 2 is 4, 2 times 1 is 2, and this is the resulting matrix of that matrix multiplication right here. Now, the question doesn't ask us for C times A, it asks us for C times A transpose, so we can do that. We just take CA and we transpose it. So we get the rows become the columns. So here we'll get 2, 4, 8, and the second row will become the second column, so 6, 4, 2, and this is the answer to bit D. Now we can go ahead and do bit E. So in bit E, we just take C and multiply it by A transpose. So we already found A transpose, and we just have to multiply C by that. I'm just going to write out A transpose again, because I erased it. So it will be 1, 2, 4, and 3, 2, 1. And we just should multiply this by 2 since c is 2, and that equals, well, 2 times, I'll just write that out. 2 times 1 is 2, 2 times 2 is 4, 4 times 2 is 8, 2 times 3 is 6, 2 times 2 is 4, and 2 times 1 is 2. And if you notice here, we get that c times a transpose is equal to c times a transpose. Well, it's clearer to see here than me telling it because I can't see these brackets, but yeah. So the second property that we got is that, well, I'll just write out the first property. We got one property that says that A times B transpose is equal to B transpose A transpose. That's the first property that we derived. The second property that we derived is that CA transpose is equal to CA transpose. So whether you multiply C after the transpose or before the transpose, you'll get the same thing. And these are the two properties that we arrived at after doing this example. Once again, this isn't a proof of these properties, it's just me showing you using an example that these properties are true. So those are two of the properties that you need to know for the transpose of a matrix. And there's one more I'll just go down and show you. I didn't include it here because it's actually kind of intuitive, but these are just the properties written out in more formal terms. Well, there's two more that you need to know. The first is that the transpose of a transpose is just equal to the matrix, and that makes sense because, well, we're switching the rows by the columns, and then switching the columns by the rows again, so it makes sense it will arrive at the exact same matrix again. And the second property is that A plus B transpose is equal to A transpose plus B transpose. This is called the transpose of a sum. And this makes sense because we're just adding the two matrices and finding the transpose. Whether we add rows to rows or columns to columns, we're still adding the same respective entries. So we'll obviously still get the same thing at the end. And the last two I showed you over here, AB transpose equal B transpose A transpose, and CA transpose is equal C times A transpose. So, and I'll just recap what a transpose means because that's probably the most important part of all of this. When you find a transpose, all you're doing is you're switching the rows and columns of that respective matrix. So yeah, that's pretty much a few of the transpose properties that you need to know. And the transpose is an incredibly important operation when we get into the further parts of this course. So make sure you're comfortable with this.
I just wanted to thank you for sticking around until the end of the video. It really does mean a lot to me. If you have any questions, you're welcome to leave a comment and I'll try and respond as quickly as possible. On screen, you should see a link to a playlist containing every single one of my individual linear algebra videos that I made so far and the ones that I would have made in the future. So go ahead and check that out. You should also see my last video. So if you're a little bit confused in this one and want to see the previous concept, you can click on that. And finally, you should see a subscribe button. And if you want to be notified for my future videos and also wanted to tell me that you enjoyed this video, you can do that. Okay, cool. So that's it, and until next time, bye!